All right, so welcome to problem number 242 in Leetcode. And this one says that given two strings S and T, return true if T is an anagram of S, right? And return false if it's not an anagram of S. Okay, now what is an anagram? An anagram is a word or a phrase formed by rearranging the letters of a different word or phrase. So if you have two words, like over here, S and T, right? Can S and T be anagrams over here? So let's have a look at what S and T are, right? So S contains the word anagram and T contains the word nagram. And you're gonna say that it's true that these are anagrams of each other. And how are you gonna know? Because S and T are essentially, T is essentially S, but the arrangement of letters is just a little modified over here, right? So if they contain the same letters, exactly the same number of times, but just the arrangement is a little different, then we can call these two words anagrams of each other. Does that make sense? All right. So let's have a look at example number 2. Rat and car, are these anagrams of each other? No, because why? Rat and car, they have the same length, but over here S contains the letter T, whereas T does not contain the letter T, rather it contains a C, right? So you don't have exactly the same letters over here to begin with, right? So they're not anagrams of each other. Now, how are we going to solve this problem? To be honest, the brute force approach that we usually follow is basically what common intuition you're going to use to solve this problem, right? So let's say if you want to solve this problem, how are you going to know? How are you going to think to solve this problem? Given that, let's say you're given two words just on a paper and someone asks you to find whether these two words are anagrams or not. So you're going to see if these two words have the same characters or not first, and whether they exactly appear the same number of times in both the words, right? If these two conditions are maintained, then you can say that these are anagrams of each other, right? So that's what we're going to do over here. So we're going to build two frequency counters, right? So the frequency counter is basically going to count the number of times each letter has appeared in S, and then the number of times each letter has appeared in T. And then we're going to see that if this number of times, if the letters in S and T are firstly the same or not. So if there's a different letter, then we can straight off say that they're not anagrams. And then we're also going to check if the letters are the same, the number of times each letter appearing in S is the same as the number of times each letter is appearing in T or not. If both these conditions are met, then we can say that S is an anagram of T, right? So to do so, we can start off with building a frequency counter, right? So we are gonna build a frequency counter for each word, right? So for S and for T. So let's say we have this, and this is the frequency counter for T. So S is going to have A. So how are we going to count the frequency? We're going to iterate through the whole of S. For each letter that we see, we're going to see that if that specific letter is already in the frequency counter here or not. If it is not, we're just going to add it. So we're going to make a dictionary. So it becomes really easy, right? Because dictionary, we have already seen that dictionaries, give us a constant lookup time, right? So the lookup of whether something is present in a dictionary is basically very efficient. So that's the beauty of using a dictionary in Python, right? So we're going to see if that character is already inside the dictionary or not. If it is not, we're going to add it. If it is, then we're just going to increase the frequency by 1, right? And then at the end, once we're done building both of these frequency counter for S and T's, we're just going to compare if they're the same or not, right? So how are we going to compare? We're going to check firstly whether the keys in the dictionary are the same or not in the first place. So that would mean that we have the same letters. And then we're also going to count the frequency of each letter, right? If both of these conditions are met, then we can say that S and T are anagrams. So let's start off with it. So A is going to appear first over here. So A is going to be 1. Then N. It was not in the dictionary, so we're going to make it 1. Then A comes again, so we're going to make A to 2, right? And then we end up with G. So G comes again. Oops, sorry. So we have G, 1. Then we have R, again 1. And then we have A coming up again. So we're gonna increase the counter of A from 2 to 3. And then we have M. So we have M. So we're gonna make M1, right? So that's the frequency counter of S. Then we're gonna make the frequency counter of T. So we're gonna start off with N. So N's gonna be 1. Then we're gonna come to A. So we're gonna make A as 1. Then we'll come with G. So G is gonna be 1. Then we're gonna find A again. So we have already seen that A is already here. So we're gonna increase the counter of A by 1. So A is gonna be 2, right? And then we're gonna have R. So R comes again 1. And then we'll find A. So A is already over here, right? So we're gonna just increase this counter by 1, right? So A is gonna be 3. Sorry. And then we'll have finally M. So M is gonna be 1, right? And then we're gonna see if both these, to find whether these are anagrams of each other, we're gonna do exactly the process that I said before. We're gonna look through all the keys and see if the keys over here are exactly the same, if there's any different key that we have. And then we're gonna also check for each key if the value for S matches with T's frequency counter, right? If both of these conditions satisfy, then we can say that S and T are anagrams, all right? So let's have a look at so over here, this thing is maintained, right? So the Drake frequency counter over here. So if you look at A is 3, 3, N, 1, 1, G, 1, 1, R, 1, 1, M, 1, 1. So we can say that S is an anagram of T, or vice versa, all right?
All right, so this is the part where we code, and as we said, we're gonna have 2 frequency counters, and for frequency counters we're gonna use dictionaries, right? So let's create a dictionary for S, which is empty, and then we create a dictionary for T, which is also empty. So there are also counter methods which is definitely gonna build you this frequency counters directly. All right, there are methods to do that. There are shortcuts, but I'm not gonna do it. So I'm going to build it manually. So for I, now if you ask me why I use dictionaries, it's because it's very efficient, right? You have that constant lookup time. It's so beautiful that, if you want to look up if something's present inside or not, usually if it's an array or if it's a list, it's going to take on order of n. So it's linear complexity, but if it's a dictionary, that lookup function is basically constant time. So it's so beautiful. So that's why you use dictionaries, right? So for I and S, I'm going to populate dictionary of S. So dictionary of S is equals to 1 plus dig of S, dictionary of S dot get. Here's 0, right? So there's how you build the dictionary for the string S. You're going to do the same thing for the string T, right? So for J and T, we're going to do dictionary of T is going to be 1 plus dictionary of T dot get J, comma 0, right? Alright, so now that you have built up the frequency counters, your first thing is that you want to see if those 2 conditions, if the keys are there, and if the keys are exactly the same, and if the keys are the same, then the frequency of each of those characters, whether they're the same or not, right? So first condition, if dictionary of S dot keys is not equals to dictionary of T dot keys, then I'm going to return a false, right? Or if they're the same, then I'm going to have another condition. So for KV in dictionary of S dot items, I'm gonna check if v is not equals to dictionary of t of k. So for that specific character, if the value is not the same as what you would get in dictionary of t, so for the specific character in dictionary s, if the value is not the same as what you would get in dictionary k, in dictionary t, then you're going to return a false, right? So alright, so these are the conditions where you return false. If both of these conditions are not met, that means they have the same number of same keys and the value for each key in both the dictionaries is the same, then and then only you're going to return a true. Alright. Oh, sorry, my bad. Well, there are times you forget stuff, so you gotta build upon it. Alright. Alright, one more thing. Yeah, so I don't know why this one never gave it through as an error. Okay, so yeah, if we run it, there you go. It's a really good solution.